What's the correct partial fractions?
A divided by x plus 3 plus b divided by x plus 3 squared.
Okay, go ahead and find your end. Mr. Aldane says that if you want to do a partial fraction for this, you will notice that there is a repeated factor of x plus 3 here, x plus 3 squared. Right, Mr. Aldane?
Yeah.
You will have 27x plus 54
Equals.
over x plus 3 squared, and so you have a repeated linear factor. The correct partial fractions for this is a over x plus 3 plus b over x plus 3 squared. Is that correct, Mr. Aldane?
I believe so.
So now you go ahead and find a and b. Yeah, small people don't know how to do division. This is a fact, and it starts in middle school. When the kids do when they do division in middle school, they have no idea what they're doing.
I can do regular division.
No, you can't.
Throw letters in there.
No. I assure you, you probably don't understand the regular division. I'll show you in a minute. Most people don't understand division. Mr. Aldane, what did you get for A and B? Or would you like me to do this? I'll do it quickly. Clear the fractions. What do you get? 27x plus 54 is equal to what?
A times x.
Plus?
Oh. Oh, that's why. Okay.
Plus?
B.
B. Okay, what do you put in here, Mr. Collas? X equal to? Negative 3?
Yeah.
Okay, when you put x equal to negative 3, what do you get here?
Apparently I don't have full fractions.
Negative
Negative 27.
27 is equal to?
B.
B. So B is negative 27. And you know now your pre-calculus function. So you're very excited. Say, no, what is another value of x you would like to try, Miss Yasmina? 0? 0. What's this? So what did we say B was? Negative 27. Miss Yasmina, when you put 0 here, what do you get? 54. And when you put 0 here, what do you get?
A times 3.
3a minus 27. So what is A? Huh?
18.
I can't math.
No, don't ask me. I don't know numbers.
27.
27. Very good. 27. So this is what do we have? Okay. And you can go home and integrate that.
Did you put a cube? Accident?
Bees. My bee. My bee. This is my bee.
Somewhere on that side. Oh, I see.
All right, the last case.
How does 8 equals 27?
I'm going to ask you all math 99. We'll add 27 to both sides and divide by 3.
Okay.
If you plug in negative 3, don't both of them cancel out because you get 2 zeros.
There's nothing to plug into B. B is
Oh, what's that? Mr. Harris. When you clear the fractions here, what do you get? You want me to do some algebra for you? Clear the fractions here. I'm going to multiply both sides by x plus 3 squared. I will get 27x plus 54. Multiply by x plus 3 squared, I'll have 8 times x plus 3. Are you with me?
Yes.
Multiply by x plus 3 squared, I'll have b. Are you with me?
So,
Are you with me?
okay.
Do you know how to clear fractions? Good for you. I'm not going to be doing too much algebra. I don't teach college algebra anymore. Gosh, I don't want to teach that class. The dean wants to torture me into giving me college algebra to teach. Now, the last case, Mr. Bess, is what? What is it if you cannot factor the denominator? And there are things we cannot factor, right? Anybody know something they do not know how to factor? I do not want to shame anybody, but anybody know how to factor this one? Mr. Boshi, is it that? If you think you factor it like that, you are in the wrong class. Okay. Be assured that you cannot factor that thing off that. Because when you plug in -1 here, you will get 0. When you plug in -1 here, you will get DOS. You know you have not factored it correctly. If you really want to know how to factor this, you know it should be this. That is to say, the zeros of this thing are I and -I. You don't believe me? Let's see. Plug in I here, what do you get? 0. Let's do it here. I times I. -1 plus 1. Yes. Let's try -I. Plug in -I here, what do I get? 0. -I times -I. I squared. I squared is -1 plus 1. That is how you factor it, if you ever wanted to know. But anybody try to factor that with the real numbers, you can't do it. We call this irreducible quadratics. Irreducible quadratics. So that is going to appear in your Q. That is going to appear in your Q. So something like this. Factored! Not factorable using the real numbers. Go home and think about it. You can't factor this using real numbers. That is to say, you cannot find the real zeros. If you want to know why you cannot find a real 0, take your x squared and shift it up 25. It's never going to be 0. So we cannot, Mr. Aldane, factor this any further with the real number. This guy, you would do what with the partial fraction? You would say what? This guy, you would say what? Because you cannot factor it. Ms. Yasmina, are you with me? This may be 2. This may be 5x plus 3. I don't know. But you don't put a 1 there. You don't put a b here. That's not going to work. Because it's a quadratic that is irreducible. Now put your pen down. If this number was a 5, would your calculus 1 friend be jumping up and down? Yes. If this number was a 2, would your pre-calculus friend be jumping up and down? Yes. That is a new substitution with the logarithm. Follow me. Take a look at your note from last time. Told you how to integrate this. And if this was a 7, would your pre-calculus friend be jumping up and down? They would tell you what? Inverse tangent. Take a look at your notes from last time. So, your pre-calculus friend is saying what? He's jumping up and down. He says, give me these numbers, I'll tell you how to integrate it. Follow me. Now, just give me those numbers, I'll tell you how to integrate it. So let me do one and then I'll tell you how you do it in general. Somebody says to you, integrate this beast here. You say to yourself, well, the degree of the numerator is less than the degree of the denominator, so you say to yourself, okay, well, that's good. And then I try to fact, the thing I said, give up, can't fact, so that's the You say to yourself, well, that one's already fact, it's not a problem. But this one here is irreducible quadratic, there is nothing I can do. But say maybe it's something like this. Now you go home, you check it, you multiply this and multiply this. And you get this. Now, how do we find the A, B,